We're actually going to be talking about two different skills today. The first being how to find the greatest common factor of a group of monomials. This is based exactly on what we've been doing with how to find the greatest common factor of two numbers. Let's take the numbers 36 and 54. If you recall, the way we find the greatest common factor, actually I'm going to move this over. The way we find the greatest common factor of two numbers is to first find the prime factorization. I'm just going to do this for you. 36 is 2 squared times 3 squared. 54 is 2 times 3 to the third. To find the greatest common factor, we look for the primes that are in common. So in this case, they have 2 in common, and they also have 3 in common. We take the smallest exponent of each, and then we multiply these together. 2 times 9 is 18. So if I just expand this notion one step further to have variables involved, I can say 36 a to the second b c to the third, and 54 a to the third c squared. I already know that the greatest common factor of 36 and 54 is 18. So now I'm going to apply the same exact reasoning to the variables as I did to the primes. These have a's in common. I use the smaller exponent, a to the second. They don't have b's in common because there is no b in this monomial, 54 a to the third c squared. So they have a to the second in common. They do not have b in common. They do have c in common, and the smaller exponent is c squared. So the greatest common factor of these two monomials is 18 a to the second c squared. To list the steps or words that go with this, the first thing you want to do is find the GCF of the coefficients, or the numbers in front. If it's not immediately apparent, you may want to use prime factorization. And as I said before, we're going to, from now on, call that PF. Then, just like we did with the prime factors, we are going to take the smallest power of the common variables. Okay. So, let's do another example. Let's say I've got 54 x to the third y and 81 x squared y to the fifth. So let's take a look first at what the prime factorization of 54 is and what the prime factorization of 81 is. 54 is 6 times 9, which is, or actually maybe this is one time when it helps to say it's 2 times 27, which is 2 times 3 to the third times x to the third times y. 81, we know 81 is 9 times 9. Each one of those 9s is 3 squared. So 3 squared times 3 squared is 3 to the fourth, x to the second, y to the fifth. Looking at these, the only prime they have in common is 3. And the smaller power is 3, so it's 3 to the third. They have x's in common. The smaller power is 2. And they also have y's in common. So this is 27 x squared y. Do make sure that you understand this, because it is a very key concept in this entire unit. The second skill we're going to look at today is dividing a polynomial. And hopefully you remember that poly means many, so it's many terms added or subtracted together by a monomial. So for example, as always, we're going to base this on what we already know about arithmetic. If I say to you 2/7 plus 3/7, I think you all know that the way we add fractions is to add the numerators and the denominators stay the same. So in other words, if I started out with 2 plus 3 over 7, that's the same as 2/7 plus 3/7. The reason why this is useful is because if I have the polynomial 5m plus 35, and I'm dividing it by 35, if I'm dividing it by 5, I use the exact same concept. I can divide it into two separate fractions, just like I did over here. 5m over, I can call it 5m divided by 5 plus 35 divided by 5. These are easy. That means that the answer to this problem is m plus 7. What that means is 5m plus 35. That's the reason behind the idea, the big idea when I'm dividing a polynomial by a monomial is to divide each term of the polynomial, which is the numerator, by the monomial, or the denominator. So I'm going to put that in words. Divide each term of the polynomial, which is the numerator, by the monomial, which is the denominator. Okay? So let's take an example that's a little bit more complicated. If I say 3x to the 4th plus 6x to the 3rd y minus 3x squared, and I want to divide it by negative 3x squared, I could rewrite it with each of these terms as a separate fraction, 3x to the 4th over negative 3x squared, 6x to the 3rd y over negative 3x squared, negative 3x squared over negative 3x squared. But personally, I think in the end, it makes sense to try to get so you can just think 3x to the 4th divided by negative 3x squared is negative 1x to the 2nd, because in division I'm subtracting my exponents and they go where the exponent was bigger. When I divide these two things, I get a positive divided by a negative is a negative. 6 divided by 3 is 2. X to the 3rd divided by x squared is x. I'm subtracting the exponents and they go where it's bigger, and there's still a y up there. Here's the challenging part. To divide negative 3x squared by negative 3x squared, first of all, a negative divided by a negative is a positive. And we're so used to thinking that they just cancel out that some kids believe that that makes it equal to 0. But really, they cancel out because in a multiplication or division problem, because any number divided by itself actually equals 1. If you don't remember the 1, then it's not entirely correct. I think that you have enough examples here to do your homework. Remember, these are the steps to dividing a polynomial by a monomial, and the greatest common factor just follows the same exact rules as we used when finding the greatest common factor of integers.